All right, guys, we're gonna get started. Sorry, we're starting a little late today. I was working with Professor Kim on something with the curriculum. So today we have two things on the agenda and then a reminder. Right. So the first thing, the first half of today will be a lecture, just continuing reinforcement learning. Right. As you know, the main idea here in something like a course like this is to look at transfer learning, right? And transfer learning is about fine tuning and then reinforcement learning, right? So reinforcement learning through human feedback is a complex topic, right? And it's sort of the end of reinforcement learning. The lectures, this sequence that we've started is, covering many of the topics of reinforcement learning. So last week, we covered so far we've covered the concepts of transfer learning, and then we started reinforcement learning with one topic, right? Do you guys remember which one that was? What was the reinforcement learning algorithm that we looked at last week? It's going to be on the exam today. Q learning, right? Q learning, right? So we looked at tabular Q learning, and we've also looked at how to do an environment for a GPT, right? So that's also something that we've covered, environments. Q learning today, we're going to cover Q learning instead of a tabular Q learning with a table, we're going to cover Q learning with a neural network, all right? So the code is going to be very similar to what we did last week, but this time it's going to have a neural network instead of the table, right? And so we're going to go over that. So that's the lecture for today. Going forward, those are Q-based, value-based reinforcement learning algorithms. Going forward, we're going to switch to something called policy-based reinforcement learning algorithms, PPO, DPO, and GRPO, right? So the new one for DeepSeek. So we're going to continue with that discussion. So today we're just covering one topic. Deep Q learning is what it's called. And so that'll be the first half of today. The second half of today will be, as you know, exam one, right? So you'll have your exam during the second half of today. Okay. And then, so those are the agenda. And then the reminder is that we agreed that you guys are going to do demos of your homework assignments next week, right? A week from today. So I'm really looking forward to I'm going to bring some investors now, but I'm really looking forward to your AI agents homework, right? So I want to see what you guys have done. And so you'll demo those and, whatever other homeworks we have time for, like the BERT models is the second one. I don't expect any results on the RLHF yet, and that's not due for like 3 weeks, I believe, right, from today. Any questions for me, guys, before we begin? No questions? Everything making sense? I know I posted some papers. I don't expect you guys to memorize them or anything, but that you should be reading at least the abstract and a little bit of them. They are essentially the history of reinforcement learning, all the way to reinforcement learning through human feedbacks and GPT, and as they apply to transfer learning and GPT. If there's one paper you should read, it's the Siegler paper. It's essential. But obviously, I'm covering these topics in the lectures. Anything else? Any questions? Yes, sir, please. More, what's the second option? More conceptual. Today's exam? Today's exam is, initially we've covered less theory so far, right? So initially we started with AI agents, was more about how to use models. It's been inference, right? So I started a lot with inference, which means you're not really training or using the ideas of, training neural networks. You've just been doing inference. So there's questions like that, just code how to instantiate a GPT with transformers. Although there are some questions on what is transfer learning and what is Q learning, which is the topic we've covered so far. Exam 2 will likely be more conceptual based, as you said, more math based, as we will have covered many other reinforcement learning based techniques. All right, great. So yeah, oh yeah, please go ahead. It'd be great. I definitely want to see the AI agents homework. If you have it, I'd like to see some of it. It'd be great. But the deadlines are still whatever they are on Brightspace, right? I just, whoever, sometimes some students are done and others aren't. So there's no rush, and you have until the deadline that I set on Brightspace to submit the homework. Yeah? Anything else? All right, great. So let's get into it. So I think let's go into 5:30 here. Content. So as you can see, we are about here, I would say. Reinforcement learning. Oops. Right, and Q learning. So I gave you these two links, which essentially they take you to the code. Okay, so let me actually do something. I'm going to break this